Last question, C. Also about the malonic acid. They ask us to calculate the concentration of each species if another half of liter of 0.6 molar bromide acid is added to the solution. Okay, so I would assume that they means that we keep adding more acid to the solution that have been mixed with some salt already. So this is the bromide acid, and then this one is also a very strong acid. So it will dissociate into the proton and the bromide ion. And based on the concentration, 0.6 molar times with the volume, we got the number of mole of the acid is 0.3, and then we can figure out the number of mole for the protons and also for the bromide ion. So here we see that before the acid is added, the solution have an amount of proton to be that much already, right? Like from the concentration. Oh, and this is the case when we have the salt added is a malonate salt. Okay. Here, so we got the proton concentration again is this one, and by the total volume of the mixture of the salt, the solution of the salt and the acid before, we can find the number of mole of the proton to be this much, and now we have another 0.3 mole added. So now you can see that the total number of proton at this point, right after we add the acid into it, is this much. Okay, and now we can see if you compare this amount of proton with the amount, the number of mole of the hydrogen malonate, this one, then you can see that this one is much larger, right? This one is much larger. So I could say that because it's a lot larger than this one, then there will no second dissociation happen. And this one, but it's also less than the amount of the acid, the malonic acid is this much here. We can also figure out this one because this is the concentration before adding the acid times with the volume, and then we got this is the concentration of the malonic acid. So we can see the number of mole of the proton is less than this one. So it means that the reaction, the dissociation still occur for this one because the number of proton is still less than this one, so it's still like keep going in this direction. So that's why we can see that only the malonic acid dissociate into the hydrogen malonate and the proton, but there's no second dissociation. Okay, that's the key. Why? Because when we know that, we can say that okay, now in the solution there should be water for sure, and then there should be the malonic acid, and then we can see this is the number of mole, right? Now the volume has changed because we have add two solutions together. I mean a solution of the mixture between the acid and the salt, and then the solution of the acid, the bromide acid. So that's why we got the total volume right now is 1 liter, and that's why the concentration of the acid has been decreased. Okay. And then now for the salt cation, here I just pick sodium as an example. If you remember, just to have this one is more specific, easy to write. But it can be any like cation for the salt, okay? And basically we can see that this is a disodium or like any other metal. It should be like twice the concentration of the salt. So we can see that the number of mole, okay, then divided by the new volume, then this is the concentration of the salt cation, okay. Then now for the hydrogen malonate, we can see that the number of mole is this one, right? We have mentioned about this one here, right? This is the one. This one is the amount that have been dissociated from the malonic acid. And then we divide it by the, by the new volume. We multiply with the original volume to get the number of mole. Then we got the number of mole divided by 1 liter as the new volume. Then we got this one. So this is the concentration of that species. Now this one we have, this is the malonate group from the salt, right? This is like from the salt added, okay? It is not from the dissociation of the acid itself, but it is from the salt added, okay? So that would be the 1.2. And then we can see that that's what like 1.2 molar for when it's still like just half the liter. So then the number of mole to be like 0.6 mole, and then divided by the new volume, then we got it to be like 0.6 molar, okay? And then the proton, okay, so now this time proton will be the new added from the bromide acid, also added with the amount of proton dissociated from the first dissociation, okay? This is the amount of proton from the first dissociation here. This one here, okay? If we multiply this one with the half of the like we just say here, right? This one here, yeah, it's here with half of the volume. Then this is the number of mole of the hydrogen that being dissociated from the acid, and then adding with this one from the bromide, then this is the total mole of the proton, and then we can find the concentration divided by the 1 liter, the new volume again. So then this is the pH. We can see that the pH is pretty low now, right? Because it's indicate a really strong acid because we have this one, a strong acid added to the solution. And then finally, this is the bromide ion, basically just the 0.3 mole divided by 1 liter, and we got it to be like 0.3 molar. Okay, so this is those on the species and its concentration if we add the malonate acid. My bad, when we add the malonate salt, okay? But what is the case if we have the salt as the hydrogen malonate salt? It will be different a little bit. So what's the difference here? We can have a look. If you recall that in case of this one, we will have all the solution before adding the acid. Basically, it's just this species here, right? It's have a really high molar right now. Also the hydrogen, and we don't have the first dissociation, okay? So the acid stay the same, okay? And this amount of ion here is actually from the salt, okay? This is from the salt added, okay? So that is before. And it's just like this is like from the salt added, but a part of it will go through the second dissociation. So in the solution, we will have an amount of the malonate ion as well. That will be just this much, okay? So that's the solution to begin with. Now we add the bromide acid into it. Then you can see now, in order to calculate the number of mole of the proton, you will have that will be the 3 mole, the 0.3 mole from the bromide acid, and then added with this amount. So how can I got this one? Okay, I got it from the salt and acid solution before. So this is the amount. This is the molar of the proton. I multiply with the solution before adding this one, okay? So that's why this is the number of molar hydrogen before adding the acid. So then together we have this much of them, okay? And if we compare this one with the concentration of the hydrogen malonate group, we can see this one is pretty large. So what does it mean? It means that the reaction of this one will keep going this way, okay? because this one have more concentration than this one, so it can keep going this way. It also means that the second dissociation still occurring. Okay, so it means that this ion still stay dissociate into this one and this one. But for this one, for the acid, for the malonic acid itself, it does not dissociate, right? Because the concentration of the acid here is much less compared to this one. So the reaction go in this way, right? Makes sense, right? So no dissociation for this one. It means that no first dissociation, just the second dissociation. So based on that, we can see that for now in the solution, we of course have the molecule of the water as a solvent, but we don't need to calculate the concentration of them. Then we have the acid, which stay unchanged. So that's why we got this is the number of mole based on the concentration and the 0.5 liter to begin with, Then we got this one divided by the new volume because we have add another half a liter of this acid into it. So then we have now the concentration for the acid is 0.4 molar. Then for the salt cation, again, it will just be any cation, okay? Sodium plus here is just an example. And because to begin with here, this is just a hydrogen malonate salt, or like it's just a mono sodium salt. That's why the ratio here is a 1:1. So the concentration for the sodium is just the concentration of the salt. And that's why we have this is the concentration of the sodium, or like any salt cation, plus times with the original volume. Then we got this is the amount of in mole, then divided by the new volume again, and then we got it to be 0.6 molar. And then here we got the hydrogen malonate species here. We got the number of mole here, right? We just mentioned it here. Then we divided by the 1 liter. So that should be like this value. And then it can be rounded up to like 0.6 molar. So I could say you can see that it's not much difference between this one and this one, right? Like basically all the on of the species comes from the salt added. Okay, now we also have a little of the malonate group because that would be the second dissociation here. So you can see this is the little z here. That would be the concentration of the malonate group, and then you multiply with the original volume. We got the number of mole, and then divided by the new volume as 1 liter. Then this is the value, and you can see the concentration is very little, right? It's very little compared to the other concentration. Now for the proton now is this much here, okay? So now just divided by the new volume, then this is the number, the concentration of the proton, and then we can find the pH. So actually, you can see that if we just take like one significant figure, this one is like 0.5, and then compared to the previous one, this one is also like 0.5, but there's some little difference, right? Here, this one is like close to 0.5. It's less than this case a little bit. So that's why I just want to highlight that the pH, even though it do not difference too much, depends on the salt, but there should be still a lot of difference, okay? If we really want to look at the precision of the measurement. And now this is the primary concentration. So the thing is that it's not only about if we got the right pH or like an approximation of the pH, but we actually really need to know the chemical mechanism inside the solution. And it will highlight a really huge difference between if we got adding the salt or adding the salt, right? Okay, so I guess that it kind of looked a lot, right? But I will also share with you the note for this file, and you can also like follow it easier. Okay, please let me know if you have any question. Thank you. Good luck.